Hello, everyone. In this lesson, we're going to determine the even odd functions. That these questions are selected from calculus text, okay? And we're going to use, first we're going to review even odd function by two different ways. One is using the unit circle. One is using unit circle. So we need to understand what's the definition of even function, what's the definition of odd function, right? We covered that before. So let's review these concepts. So even function, meaning what? When the input are opposite, right? When the input are opposite input, okay? Opposite input, and they produce the same output. So when we have this kind of function, and we call it even function, opposite input produces the same output. Odd function meaning that input are opposite and output are also opposite, right? So instead of the same, they're opposite. So one is the negative of the other. So that's the even odd function definition. So from if you're pretty good with the unit circle, you can tell, right? You can tell from unit circle, right? Suppose that I'm going to measure the angle. Let me see, I can measure the angle. Okay. And now the angles are opposite, right? So suppose that we're looking at sine function. Okay. So the function we're going to look at is sine and cosine. But first look at sine. Okay. Sine function. So what we're going to see is that if sine of angle A, how is this related to sine of opposite of A? Okay, we don't need the parentheses for the first one. For example, you pick any angle. Okay, you pick any angle. Suppose you look at a positive pi over 6 and negative pi over 6. They are opposite. And you look at the blue number. The blue numbers are negative. They are opposite. If you look at angle pi over 4, and this is a negative pi over 4, and their blue numbers are also opposite. So sine, of course, this is not a proof. This is just showing you it is an odd number, right? And if you say, okay, I'm going to look at arbitrary situation, that will be considered better proof, is that I just drew a picture here, right? And we want to observe sine, cosine. I'm sorry, I'm just observing sine. So this is the angle A, right? And this is a negative of A, opposite. And sine ratio is a blue over R. The blue, the opposite, R is positive. Therefore, the ratio is going to be opposite. So this is negative. So sine is odd. How about cosine? So let's look at cosine A. And sorry, not equal yet. Okay. And cosine of negative A, right? Cosine A, which is going to be red over R. and the cosine negative A is the same red over R, and they have the same R, and they're both positive. R are positive, therefore they share the same red, therefore cosine is even. Okay, so now we can go back here. Okay, we can go back here. And we have determined that sine is odd. Okay, sine is odd. Meaning that sine is odd. If sine is odd, cosecant is also odd. Because cosecant is 1 over sine. Even is cosine. If cosine is even, secant is even. And let's look at tangent. Right? Tangent, we can use the same relationship. Okay, so look at tangent. Okay. Let's go down here. If we look at tangent, so let's look at tangent of A and tangent of negative A, right? Tangent A is blue over red. And the negative A, okay, so we're gonna mark these two angles. This is A, and that's negative A. They share the same red, and blues are opposite. Therefore, right? Therefore, these two are going to be opposite. So these will be negative. Oops, sorry, negative. Because they share the same red. And one blue is positive, the other one blue is negative, right? So tangent is odd. If tangent is odd, cotangent, right? Cotangent A is red over blue, right? Cotangent. So it's the same scenario. It's just reciprocal of it, right? So in this case, cotangent is also odd. So we have determined that these functions, even odd situation, right? Tangent and cotangent are also odd. Okay, so let's put them this way, right? Even function, odd function, right? So what does that mean now? Okay, so let's write the mathematical expressions of even odd, right? This means, okay, sine of x, right? Let's put it this way. Sine of negative x is negative sine x. Okay. In similar way, cosecant is also odd. So cosecant, tangent is odd, right? Tangent is odd. So I need to put them on the top. Well, these are odd functions, right? So tangent of negative x is equal to negative of tangent. And cotangent, the same thing is true for cotangent. So among all six trig functions, we got even odd verified. Okay, odd function. Even function, okay. Even function, meaning cosine of negative x is equals to cosine x. And the same is true for secant. Okay, so these will be the useful mathematical expression that we're about to use. Okay, we're about to use. So now we're going to demonstrate or determine the even or odd or neither of the remaining 5 functions. Okay, so let's start from the first one. The first one, in order to determine even odd, we're going to have to evaluate f of a negative x. F of a negative x is equal to, all the x will be replaced by negative x. Okay, so this x will be replaced by negative x. Okay, oops, negative 1, sorry. And now sine of negative x, right, is equals to negative sine x. So that we got. So that's going to be negative sine x. And the bottom is 1 plus negative x squared is the same as x squared. Okay? And then we're going to bring the negative sign outside. And then we will have sine x over 1 plus x squared. And this latter piece is f of x. So we have a negative sign in front of it. So we got a negative of f of x. We have just demonstrated it is odd. Okay? Because the following reason. Okay? So this is how you show a function is odd or not. Okay? You have to demonstrate f of negative x is negative of f of x. And of course, that is true for any number in the domain. On this one, we're going to be doing the same trick, right? So we know f of x, so we're going to replace x by negative x. So everywhere x will be replaced by negative x. And tangent of negative x is negative tangent x. So we're going to use that. So the top would just be negative tangent x. The denominator will, negative x squared is the same as x squared. Negative x to the power 4 is going to be it's the same as x raised to the power 4. So once again, we get tangent x, negative of tangent x. We got negative sign in front of it. Denominator copied. So once again, we get a negative of f of x. This is our function again. So we got the conclusion, we got the reason, okay? Now, the next one. Is it even or odd? So we're going to do the same thing, okay? So f of negative x. So everywhere x will be replaced by negative x. There, okay? X raised to the power 4 is the same as x raised to the power 4. So remove the negative sign. And tangent of negative x is negative tangent x. So we have an extra negative sign outside. Cosine x is even. So cosine negative x is the same as cosine x. So this way we got almost the same, except we bring the negative sign in front of it. So this is a negative f of x. Okay, so this function is once again is odd. So this is how we show it's odd. Okay, and there are 2 more. They are very similar. Okay, I think by this time you already got the hang of it. You just make sure you practice with it. You practice with it. Okay. So this function, once again, is because sine of negative x is negative sine x. So this is going to be negative x raised to the power 4. Oops. X raised to the power 4 sine x. So that's an odd function once more. Oh, wow. I just realized all these functions. I got all of these functions from calculus text. Okay, from calculus text. Of course, in the calculus setting, you will encounter these functions. You will encounter these functions. And to my surprise, I just realized all of them are going to be odd. Okay, so last one, last but not least. Okay, so negative x, everything x will be replaced by negative x. All right, and so now we got negative x raised to the power 3, that's going to be negative x raised to the power 3. Negative x to the power 4 is just x to the power 4. Tangent of negative x is negative tangent x. So here we go. And then we're going to factor. We're going to factor out the negative sign. We get x raised to the power 3 plus x raised to the power 4 times tangent x. So the negative sign get to be factored. So we get negative of f of x once again. So this function is odd also. Okay, so this time we have concluded to prove that all of these functions have 5 functions. They're all odd. But we also have demonstrated that, by definition, ARD, that some of these, there are 4 odd functions and 2 even functions. And that's all for this lesson. Thank you for watching.